Okay, I think we can start now. Good evening, everybody. A warm welcome to all of you to today's webinar. Over the next hour, we'll explore the why behind question making, and we'll also see why skill-based testing is extremely important in science. So let's begin. And let me begin by introducing myself and my colleague, Jyoti. Both of us work at a leading pet tech organization called Educational Initiatives, EI. EI is a 23-year-old company with a vision to create a world where every student learns with understanding. And our vision stands on three key pillars: pedagogical research, leveraging technology to scale, and the science of learning. Together, these elements guide our mission and it helps us in transforming learning experiences for students. Jyoti is an educational specialist. She holds a bachelor's degree in physics and she has contributed to a number of projects that we have undertaken. I am also an educational specialist. I have a master's degree in biomedical genetics. I have been a Teach for India fellow and I have taught students from underserved backgrounds. So, before we dive in, I want to share what we aim to achieve today through this session. First, we'll try to understand the shift towards skill based learning and why it's becoming increasingly important in today's classrooms, and how it differs from traditional assessments, which are topic based, and it's something that most of us are used to. Second, I'll walk you through how we at EI have built assets, science specific skill framework, which is actually the backbone of our question design. So we'll explore the different types of skills that we assess through our questions and how they go far beyond just simple recall. And finally, through these examples that we're going to share and the insights that we're going to share, I hope we can build a shared vision for deeper learning where students are not just learning for exams, but they're also developing the ability to think, to reason, and also to apply their understanding in meaningful ways in unfamiliar contexts. So let's get started. To begin with, I have a question for all of you, and I'd love to hear your honest responses here. So, can we have the first poll, please? The question says, have you ever seen a student score full marks and still struggle with application? Let's take about 20 to 30 seconds to quickly respond to this poll. All right, let's end the poll now. So, okay, I think I'm sure most of us are not surprised to see this response. We have seen that students are struggling with application despite very good scores in their exams. So thank you for that. And this is something we all have noticed, right? A student is acing their science exams, but then they're not able to explain the basic why or the how behind the same concept when it is asked in a different manner. And that brings us to the key paradox in education today. High scores do not always mean deep understanding. Most assessments are not designed to test whether students can apply their learnings. In fact, they're designed in a manner where we're seeing if students can remember and put down whatever they remember on their answer sheet. But are we testing whether they are able to apply this? Maybe not. So, knowing the what is not the same as knowing the why or the how behind a given concept. So let's now dive a little deeper into what science really is as a subject. First, science is an empirical field of study. What this means is that knowledge in science develops through observations, it develops through experimentations, which makes us realize that science is also very objective and logical. It's not open to interpretation. So let's say if I drop a ball right now from here, it will fall to the ground. And that does not matter, I mean, with respect to if I'm in my house right now, or if I'm in a different country, or the culture I belong to, or the language I speak, none of that matters. It's very objective and very logical. And finally, science is a process where knowledge is continuously developed. So something that was true 100 years ago, it could be proven wrong today with more experimentation, with more observation. So if one wants to really build mastery in science, it's important to not just understand, but also build skills that are required to do this observation and to do that experimentation. So academic testing in science not involves testing not only concepts but also skills. So now let's take a moment to understand why traditional assessments are failing to reveal true learning. This is an example of a question that we must have seen very often in textbooks. Differentiate between photosynthesis and respiration. And I'm sure most students would be able to give an answer for this question because they've studied that photosynthesis is a process of gaseous exchange happening in um, plants, and they're able to cook food in the leaves with the help of chlorophyll and so and so. And same way, they'll be able to respond for respiration also. And this is a simple, good question, is what we've thought so far, right? But most school assessments today are very textbook based. And like this question, most questions are seeing if students are able to recall a definition or a formula, right? Or the steps of a process. But if we put the same question in this manner, where we're asking students which of the following represents gaseous exchange of a plant at different times, and you see four different options. So students have to apply their learnings of photosynthesis and respiration and choose the correct option. So as teachers, we might know what the correct answer is right now, but how sure are we that students also will be able to select the correct answer? So when we tested this in our asset paper, these are the results we got. So while students are able to give the correct definition for photosynthesis and respiration, they're not able to give the correct answer for this question. Only 13.7% of students have got the correct answer, which is option A, and 63% of students have a common wrong misconception of what photosynthesis and what respiration is and at what times of the day it happens. So students are actually trained to repeat what they've learned and repeat what they've memorized, putting it down on the paper. They're not being encouraged to think or reason it, right? So this is leading to a very superficial learning where students know just enough to score good marks, but not enough to use that knowledge in a meaningful manner in an unfamiliar context. So a typical question that's there in a textbook probably would ask, okay, what is the gas released during photosynthesis? And that is repetition. Students know this, they will be able to say, yes, oxygen is the gas released. But if I ask them to reason this out, let's say I give them a reasoning based question, which would be, a plant is kept in a room, in a dark room for 48 hours. And at the end of these 48 hours, what will the gas released be? Will it release oxygen? Why not? Here, students might have to think, they might have to connect ideas, they might have to apply their understanding of the process of photosynthesis and respiration and give the answer here, right? Students have also become very good at mastering topics. So they can reproduce the entire content that is there in your chapter. But that does not really mean that they've understood the concept behind that topic. They may know what photosynthesis is and when it happens, but they might not be able to apply that same knowledge and that same understanding in an unfamiliar context. and they may memorize the different parts of, let's say, a digestive system, but they may struggle to explain what would happen if one part malfunctions. If you give them a slightly twisted question, they might not be able to answer that. And because we're focusing on recall over application, we're missing some of the learning gaps that students might have. And all of these things are leading to something like this, right? The students are saying, no, this is out of syllabus. If you give them a question that is not something they've seen before, this is a very common thing most teachers would have heard. So this really highlights the need for us to change the way we assess students. It also shows how students need to develop certain skills to go beyond just recall. One of the strongest validations for skill based assessments comes from India's NEP 2020 policy. So, if you see the points that are highlighted here, transforming assessments to focus on core skills for which they're setting up Parak. No hard separation of subjects and skills, right? So, NEP is clearly emphasizing on a shift that is from content heavy, rote learning based uh, uh, education towards a more competency based learning where students are able to uh, provide their understanding, they're able to apply their learnings, and they're also using their problem solving abilities. It highlights that education should be built on real life skills like critical thinking, logical reasoning, scientific temper, and not just memorized knowledge. NCF also mentions that children should be able to make sense of the world around them through observation and logical thinking. And it is also saying that they should be able to explore physical world in scientific and mathematical terms. And you see these words explore, engage, scientific inquiry, hypothesis, making predictions, being able to identify and drawing inferences. These are words we're seeing which are supporting the need for a shift in the way we assess our students and the way students learn. And the you can also see that change in textbooks nowadays, where textbooks are also promoting analysis and design, creation, all of these. And even in Bloom's taxonomy, the base is recall, but the topmost level is creation, designing, right? So we are trying to move towards that kind of skill-based learning. So the shift is not just a suggestion, it's a national direction in a lot of ways. CBSE has already started to incorporate competency based questions in board exams. Schools are also being encouraged to sort of reimagine the way they are teaching and assessing. So, what's the way forward? How do we bridge this gap between what students know and how they can do something with that knowledge? I mean, besides just being able to put it down on the paper just the way they read it, right? So, this is where asset comes in. Asset is a skill based diagnostic assessment which is designed not just to test content but also to see whether students are able to apply skills. What makes Asset unique is its two-dimensional framework. So, one part of it is, of course, we are testing topics because we cannot run away from that. Topics are important, curriculum coverage is important. So, we do assess topics, but also we go deeper and assess students on their skills. How well are they able to apply, analyze, predict, reason, design, and yes, also recall? Because recall is also an important, I mean, it is a skill one must have, but it's not the only skill that one must have, right? So we are testing all these different skills through the two-dimensional framework of asset. It gives us a very clear, layered picture of student learning. Are they just remembering facts? Can they interpret data? Can they apply their knowledge in unfamiliar situations, right? So asset is helping us uncover what maybe traditional assessments might miss: learning gaps, skill gaps, strengths, weaknesses, and all of this is going to give teachers actionable insights to take learning forward. One of the most common questions we get is which board is asset aligned to? And our answer is all boards, yet none. So, what we assess are skills and conceptual understanding, which is relevant regardless of which board a student studies in, whether it is CBSE, ICSE, IB, Cambridge, state board, anything, right? So whether the chapter is called nutrition in animals or whether it's called digestive system in humans or whatever, we're not testing the label. We're testing whether students can understand why digestion is important. How does digestion work? What will happen if a part of my digestive system stops working? That's what we're testing. So here's another question for all of you. You can use the Q&A section for this, which you'll see at the bottom of your screen. Teachers, please tell us what you think are some of the most important 21st century skills that students must develop. You can use the Q&A section and type your answers there. Let's take about 30 seconds for this. So Bindu ma'am is saying problem solving, critical thinking. Yes, definitely. Manasa ma'am is saying analyzing. Hiravati ma'am is saying AI. Yes, definitely. Creativity, collaboration, problem solving, communication, definitely very important. Designing, yes. Practical application, definitely. Yes. So, yes, communication skills, yes, definitely. Thank you so much for responding. Yes, all of these are extremely important skills that students must develop. So there are many, many different 21st century skills, and they're all often grouped under these critical thinking, creativity, collaboration, communication, and now there's also information literacy. So on the right, you can see a table, which is an example of how educators have now started building their lesson plans, where they are putting down the usual steps that they would want to see in their lesson plans, but they're also mentioning which 21st century skill is this aligned to. So they're trying to make sure that their teaching methods are also involving skill development in students. So, which skills are we assessing in asset science? So, we are going to break this down into four major pillars. The first pillar is conceptual understanding and recall. Like I mentioned, recall is an important skill to have. We cannot let go of recall. A student should be able to recall what they have learned. So under this pillar we have two skills: recollection or recognition of science facts and concepts, and the second skill is definition or description of scientific terms or organisms. Then we have the next pillar, which is scientific observation and interpretation. So here we're testing student ability to make sense of data, being their ability to observe and provide scientific explanations. So here the focus is on using known science and being able to understand it and interpret it. So under this, we have representing, relating, explaining observed phenomena, analysis of information, advanced complex data and representation, and extraction, translation, and application of knowledge. The next pillar is scientific reasoning and synthesis, where we're seeing how students are able to make decisions, predictions, connections using logic and integration. So here students have to go beyond what they are given in the question. They must be able to reason, they must be able to connect, and also sometimes forecast based on what they've learned. So this has classification, comparison of organisms or of processes, hypothesis formulation, which is extremely important, integrating different concepts for informed decision making. And finally, we have scientific tools, techniques, and investigation. So some of the some of you mentioned how practical application is important, right? Where we must be able to do some kind of experimentation. So this category focuses on the practical aspects of science, knowing how to use tools, how to conduct an experiment, how to design an experiment or some kind of activity for doing a scientific investigation. So under this, we have knowledge of scientific instruments and tools and procedures, and design of appropriate apparatus for an experiment or an activity. So these are the 11 skills that we test in asset science through our questions, and we've grouped them in this manner under 4 pillars. So let's now look at some questions and see how we are using these skills in those questions. Uh, yes, Jyoti, would you like to take over?
Yes, thank you, Purva. Hello, teachers. So, up to this point, we have developed an understanding of the importance of building and testing various skills. Now, what we will do is we will look at a few examples. We'll look at few some of the asset questions that we ask students and see how these questions help building those skills that all of us have identified which are necessary in 21st century. So I would request all of you to go through this particular question and we'll take 1 minute to do that. And after that, there will be a poll where we'll ask you to categorize this under to categorize which skill this question will fall under. So we'll take a minute to read this question. Can we have the poll now? We'll take 10 more seconds to answer and then we'll show results for the poll. I hope all of you have answered. Uh, let's let's look at the results now. So yeah, as 31% of you said this is recollection, 26% have said this is classification, uh, and some of us have said that it's can be categorized under advanced uh, or complex data interpretation or hypothesis even. So let's break down this question and let's see what this is asking. So this question is essentially is testing if students know about flammable or inflammable substances. So the diya can be formed with an inflammable substance itself, otherwise it will catch fire. So it is testing if they're able to recall what flammable and inflammable substances are, but not directly asking the definition. So this is an example of recall, uh, recollection or recognition of science facts and concepts. But we're not simply asking the definition because we know that the definition is given in the textbook and student will be very easily be able to answer that. What we're testing here is do they understand the definition? Do they understand what flammable and inflammable means and where can they use it? And as data shows, while when it comes to application, 40% of the student choose option D, where their unable to infer that since wood is flammable, it can catch fire. So it is through questions like this where, although it's a simple recall question, but we understand that students are not able to recall the definitions of these inflammable and flammable substances itself. Let's look at another example of the same skill. This question here, they just have to simply recall about gravity from their textbook. But as we can see from the data, that students are unable to effectively recall fundamental principles of gravity itself when asked in such a manner. If we'd asked them to give us definition, most of them would have gotten right the definition of gravity. But when we ask them where it acts, so some of the student thinks that it only acts when someone jumps out of the plane or when you're in air. Student think that when you're standing on the ground, then gravity does not act on you. So these are the misconceptions that we come across that the student have when we ask questions in such a manner. Moving on to the next slide. This is an example of definition or description of scientific terms or organisms. It is a very important skill in science, especially because this skill helps students grasp complex concepts, make accurate observations, and apply scientific knowledge effectively in real life situations. When they understand the definition correctly, then only will they be able to apply it in their real life or apply it whenever asked in a question. Um, Let's go through the question together. The question goes, a transparent plastic bag was tied over some of the leaves of a plant as shown below. The plant was kept in direct sunlight. After some time, droplets were observed accumulating inside the bag. We're asking which of the processes are taking place, uh, uh, both in the leaves inside the plastic bag and outside the plastic bag. And as the data shows, 27% of the students think that only transpiration is occurring because we've given them that droplets were accumulated. But since the leaves are getting sunlight, the photosynthesis will also be happening. And since leaves are breathing, so respiration will also be happening. So only 31% of the students are able to reason out correctly that all three processes will be happening, whether we tie a plastic bag on the leaf or not. Moving on to the next one. This is another example of the same skill. So here, what we're testing is we're testing if they know what transparent, translucent, or opaque objects are. Again, as all of us know, if we just ask them to define what a transparent object is, they will do it easily. But when we ask a question like this, shown here are properties of some materials. Which material shows the same property as the materials used to make red colored party balloons? So they have to identify that first of all, is the red colored party balloon, is it transparent, is it translucent, or is it opaque? And then they have to also understand what are the properties that make an object transparent or translucent. So although the question, if they understand the definition correctly, they will be able to answer the question. But if they don't understand the definition itself, a student will not be able to answer. And as the data shows, 27% of the students chose option C. So this shows us how, although it might seem that, okay, they've gotten the definition, they just have to remember the definition. But when we ask a question in such a manner, it shows us the gap between teaching and learning. So uh, if, let's say, we ask a definition, all of the student will get it. But when you ask them to relate it to real life, okay, where have you seen this? If we give them an example of a poly bag, they might not be able to apply that definition in the real life. Moving on to the next one. Now we'll see the next skill, which is representing, relating, or explaining scientific processes or observed phenomena. So this skill is very important because it strengthens understanding, it encourages critical thinking, and it enables students to connect theory with real life events. And as a result, fostering deeper learning and effective communication of scientific ideas. Uh, if they're able to relate or if they're able to explain a phenomena, that in the student, if they're able to explain something scientifically, that means they're thinking critically. They have the skill of problem solving in them. So let's take an example of this skill. Which of the following has air in it? And we've given them four options: an inflated balloon, an open cup, an inverted cup, a bottle with a lid. So now let's put ourselves in the shoe of the student and let's see how they will answer it. When they say inflated balloon, they're like, okay, we're inflating the balloon. That means we're pushing the air inside the balloon. Whereas when a, a cup it's placed upside right side up, we're not pushing any air in it, so there can't be any air. And similarly, in an inverted cup and a bottle with a lid, there can't be any air because we're not pushing any air. And this is what we show in the data as well. So 68% of the students say that only inflated balloon has air in it because they think since we're pushing the air inside the balloon, that's why there is air, but we're not putting any air in a cup or a bottle, so there will be no air. They're not able to, explain the phenomena, or they're not able to use the phenomena that air is all around us, even if a cup is kept right side up, if it's kept upside down. And when we close the lid of the bottle, some air will still be inside the bottle. But these are some of the things that students are not understanding. And through our traditional assessment, we're not able to identify these gaps as well because we're focusing more on definitions, we're focusing more on whatever is given in the textbook, have the student memorized it or not. Moving on to the next question. This is also a very interesting question. Here, what we are doing is we're testing the idea of conservation of mass, but in a very different context that they have seen. So if you ask a student to explain conservation of mass, they'll tell you what the definition is. But here in this question, they have to read the information and then they have to explain or let's say answer this question based on the concept of conservation of mass or relate the phenomena that they've observed of the inflating balloon. They have to explain it based on their understanding of conservation of mass. But as the data shows, um, only 34% of the students are able to answer or are able to relate that this, since it is an isolated system, the mass will be conserved. Whereas rest of the students say it will either increase or decrease, or they're saying that we can't say for sure. Moving on to the next one. Extraction, the next skill is extraction, translation, and application of knowledge or information. As many of you had mentioned in the chat box as well, how this is a very important skill to have. Um, uh, why? Let's try to understand why this skill is so important. Uh, they use this skill in everyday life and decision making. So let's take an example here. Let's take an example of, let's say, a student who has to go out for a picnic. So now they have to decide whether they should carry an umbrella with them or not. So what they should do in this case is they should they'll see the weather forecast. So they'll extract the knowledge from there and they will then translate that information and then they'll apply it and then they will decide should they carry an umbrella or not? So, as a simple thing as, understanding a weather forecast, or planning a trip, or planning your timetable, these everyday life decisions, so they have to apply this skill of extraction and application. So a very important skill for students to have, and it's through question like this that we can certainly build these skills, and we can incorporate these skills into their daily life without explicitly asking them to build these skills themselves. So in this particular question, the picture below shows shadow of two dogs standing in the sun. Which of the arrow below points to the sun? Now, what they have to do is they have to see the in which direction the shadow is falling, and then they have to answer. As we can see, 41% of students are choosing option A. So they're unable to reason that the shadow will be formed opposite to the direction of the sun. So hence C will be the correct answer. But only 30% of the students are able to answer option C. Moving on to the next one. Here, another example of extraction of information and its application. So this is a question of food web. They've seen food webs in their NCRT, and they know what food webs are. But do they understand what food webs are? So if we ask a student to explain what a food web is, they will be very conveniently able to do so. But in this question, so as the question says, a natural calamity led to the death of entire population of species U in the ecosystem. Um, just, uh, sorry, I have a power outage here. Are you able to hear me?
Yes, yes, we can hear you.
Okay,
Yes.
okay. Yeah, really sorry for this. So we'll continue. Um, a natural calamity led to the death of the entire population of species U in the ecosystem, the population of which species would undergo the most drastic changes. Now, here we have to see which all species are directly related to which they eat or are eaten by you. So, they have to see which species are directly or indirectly related to species U. They have to kind of extract that information and apply it while choosing their answer. And as the data shows, only 42% of the students are able to do so, and the rest of the students are not able to extract the knowledge from the food web that we've given, and they're not able to apply this information when we ask a question in an unfamiliar manner. Moving on to the next one. So this is our next skill that we're testing in our asset papers is analysis of information to identify trends or properties. So in today's world, where coding is among the most sought after professions, and coding is where most of the students are interested in, developing this skill early on gives student a valuable head start and prepares them for future opportunities. uh, so how we are testing this skill through the testing, and then in turn developing also through this question is they have to analyze which substance is being which substance is solvable in water, and which substance is insoluble in water, and they have to also apply the understanding of miscible and immiscible substances while answering these particular questions. So they know what soluble and insoluble substances are. They know what miscible and immiscible substances are. But here we're not asking them directly the definition. Here they have to analyze the information that is given to us. That okay, after 15 minutes, Q is not there anymore. So that means Q must have dissolved in the water. And P is not mixing with water, so that means it is insoluble. Um, That means it is immiscible and R is insoluble. So 40%, although 40% of 47% of the student are able to reason that out, rest of the student, more than 50% of the student are still not able to answer this correctly. Moving on to the next one. Again, another example of the same skill. So here, what they have to do is they have to read the graph. So through this question, we're also testing if they are able to read the graph. Also, they have to analyze the information given in the graph to arrive their answer. So let's go through the question together. The question says the graph below shows the number of species of fish in a small pond. What kind of animal has been added to point X? So they have to analyze that, okay, since number of fishes is increasing, so the animal that has been added should be what the fish eats. And looking at the data, what we see is um, most of the students are not able to get it right. Only 21% of the students are answering it correctly. 36 of the percent of the students say that the same species of the fish is added. Moving on to the next one. Now we'll take some time to go through this question, and the same poll will appear, and we'll try to, now that we've kind of understood how we relate a particular skill to a question. So now let's see if all of us are able to answer which particular skill this question is aligned to. So let's take a minute to go through this question. I hope all of us have gone through the question. Can we have the poll now, please? We'll take 5 more seconds to answer and then we can see the results. Okay, I hope all of us have answered the poll. Now let's go through the question and let's try to understand which skill it aligns to the most. Omar writes his, okay, let's look at the results. Some of you say it is hypothesis, some of you say it is design, some of us say that it is advanced or complex data representation. So let's go through the question. What we have here is we have the path that Omar followed while riding the bicycle, and then we're asking what will be the displacement time graph. So here, what a student has to do is they have to first interpret the particular path that the bicycle has followed, and then they have to represent this on a graph based on their understanding of displacement. So this will come under complex data representation and or interpretation. So in this one, they're both interpreting the data and representing it as well in form of graph. So this question, so here we're essentially testing their understanding of displacement. This question in normal textbook, if we say you must have seen define displacement or what is displacement. So most of the students get the definition right. But when we ask a question like this, along with testing our concept of displacement, we're also testing if a student is able to interpret the data that we've given them. Or are they able to represent the data that we've given in graphical form? As the results show, 50% of the students have chosen option B. So let's look at this particular option here as well. So here some of 50% of the students say that it is continuously decreasing. So from this option, what we understand is that students are thinking, confusing displacement with distance. So they're not taking into account the direction in which Omar is moving here. They're only taking into account the distance that he has traveled. Moving on to the next question. Um, this electroplating, in 8th grade students study this, and we ask them to define electroplating, or we ask them how the setup is built. They're able to answer that. But here we're asking the question in such a way that they have to represent the information that they're getting into a graphical form. And as the data shows, only 31% of the students are able to answer it correctly, and rest of them are have either misconception or they're not able to understand the concept itself. Moving on to the next one. Um, let's look at this question as well, and let's quickly take 30 seconds to go through the question, and then we'll have a poll for this as well. Yeah, so I hope all of us have gone through the question. Can we have the poll, please? Let's quickly take 10 more seconds to answer, and then we'll see the results. Okay, I hope all of us have answered. Now let's go through the question and let's see which skill the question aligns with the best. Um, so in this question, what we're essentially asking is we're asking students to categorize these different tissues and different cells. So this question will come under the skill of classification. Also, I would also want to draw your attention was the fact that, as most of us who taught this in class know, that this is a very dry topic, and it is very difficult to make any question other than a recall question on this particular topic. But when we ask a question like this, where we're testing this skill, it also gives us an interesting way of asking a question. Uh, if Even if the concept itself or the topic itself is dry. So all of us who are struggling to come up with interesting way to ask question from this topic, if we align this question with a particular skill, then the question also becomes interesting and not a basic recall question. Moving on to the next one. This question here, they basically have to apply their understanding of respiration, and they have to like see if the respiration occurs in only leaves or all part of the plant, or does it occur all throughout the day, or does it only occur during the day. So here also we're asking them to classify the process of respiration. So this will also come under the skill of respiration. And as we see that when we ask the question like this, only 32% of the students are able to answer it correctly. 34% of the students think that respiration only occurs in leaves, but they fail to understand that respiration will occur in all the living cells. So through questions like this, we're also able to identify the misconceptions that the students have. Moving on to the next one. This is an example of hypothesis formulation or prediction of outcome. Uh, so why this skill is important is because through this skill, students learn to think ahead, test their ideas, and explore cause and effect relationship. These are key steps both in science and everyday life, and everyday decision making as well. Uh, if a student has any ideas, asking these questions will strengthen their skill of hypothesis formulation and prediction of outcome. And as the data shows, when we ask a question like this, 28% of the students are able to answer it correctly, but most of them are not getting it right. Moving on to the next one. This is also one of the example of hypothesis formulation, uh, where we're testing the concept of magnetism, but they have to predict the outcome as well. Moving on to the next one. Let's now look at an example of integrating different concepts for information for decision making. So, looking at this question, if we simply ask them what a boiling point or freezing point is, they will be able to answer it. But when we ask the question like this, they're not able to answer it correctly. Most of the students are getting it wrong. And integrating different concept or information is this skill is also very valuable in everyday life, as it helps student. For example, if they have to choose what they want to wear, they will integrate concepts like what is the weather, what is the season, what time of the day it is. Is it afternoon or is it night? Or let's say if they're planning something. So this is a very important skill in everyday decision making as well. And by fostering this skill, by developing this skill, we're fostering students to uh, make decision making more logical and more information based. Moving on to the next one. In this particular question, they have to integrate concepts of rotation of Earth, and they also have to see that since right side of the Earth, right part of the Earth is getting sunlight, so sun is at the right of the Earth in this particular context. So they have to integrate these concepts while answering this question. And as the data shows, only 35% of the students are able to integrate both of these concepts while answering this question. Moving on to the next one. This is also a question. Let's go through the question together. Asha saw bubbles rising from the bottom of the glass vessel when it was heated on the stove as shown here. This is how she explained her observation. The flame is at the bottom of the vessel, hence the water heats up faster and forms water vapor at the bottom of the vessel. Which of the following should she do to verify her explanation? So, in this, what they have to do is they have to basically apply the skill of design of apparatus. So, this question is testing if they're able to come up with an appropriate design to test a hypothesis that Asha here has made a hypothesis, and now to test it, are they able to design the appropriate apparatus? So this is the skill that we're testing through this question. Moving on to the next one. The next skill that we're testing through our asset question is knowledge of use of scientific instrument, tools, and procedures. So in everyday life as well, we use scientific tools every day. We use a clock to see time, we use screwdrivers. Everything you can think of is a scientific instrument or tool. So having that knowledge is also very crucial in day-to-day life. Moving on to the next one. The knowledge of weighing balance. Through this question, we're testing if the student understand how balance scale works. And as the data shows, 40% of the students are going for option A. That means students don't have the understanding of working of a simple balance scale as well. Moving on to the next one. Yeah, now I'll ask Purva to take over.
Thanks, Jyoti. Um, so yes, how are we able to how is this dual approach of topic plus skill, how is this beneficial? So we're able to identify learning gaps more precisely because we can specifically say how students are probably able to do well on a certain skill and they're not able to do so well on another skill. And in a given topic, also we're able to specify that. It also helps us plan our teaching strategy a little better because different skills will obviously require different teaching approaches. For example, if there is an issue with, let's say, analysis, the skill of analysis, then maybe as teachers we will have to give them more data interpretation activities where they're able to analyze data, right? So we must remember that science is not just about knowing facts, it's about thinking like a scientist. And having these skills will help ensure that students are able to develop both of those. So one thing I want to tell all of you is that you can build these skills parallelly through your teaching. You don't have to carve out a separate teaching time or separate a lesson plan for this. You will be able to build these skills if you are able to uh, make the right kind of questions and slightly tweak your teaching methods to ensure that these skills are being taught to students while they're learning. For example, if you're learning about water conservation, let's say, so when we're doing the topic of water conservation, we're encouraging students to reflect on the real life impact and how they're able to build empathy through it, environmental responsibility, and a sense of social justice, right? So, like how they're able to build these values through your teaching, you will be able to build certain skills also through your teaching. And we would like to share some of our sample asset skill-wise reports with you. Uh, when students take up the asset exam, the teachers in the schools will be provided with reports like this, where we are able to see across subjects, English, mathematics, science, the different skills and how the students are doing. You will get your school performance and it will be benchmarked. So you will be able to compare with the national performance and see where your school is standing. You will also be able to see the strongest skill in most of your students and some of the skills that need to be worked on. Um, while we have the bigger picture of the school, we're also going deeper at a microscopic level. We're looking at the class-wise performance of students. So here, like you can see in this report, you can see the comparison of your class uh, versus the whole national average also, right? So this comparison is done for each skill, for each subject. Um, and finally, we're able to pinpoint specific questions and skills for action. So this part of the report is going to show you three questions that students of your class are able to excel at. They're able to do this very easily. And also it's going to highlight two skills that are strong, two skills that are weak. So this information can be used by teachers to focus his or her attention on specific questions and specific skills, right? So questions which are most difficult, questions which are most easy, skills which are very strong, skills which are very weak, you get a very good idea of how your students are performing. So if you have good questions, it'll help you with effective diagnosis of learning gaps. And all of this is going to help in remediating those learning gaps, and it will definitely help students learn with understanding. So, thank you so much for attending the webinar. Um, you can scan this and provide your feedback in the feedback form. Um, I'll also like to take up one of the questions that was asked by some of the teachers on the Q&A section. Ela ma'am is asking how to motivate teachers to create such skill-based questions. So I think always it's important to remind teachers that you can make skill-based learning a part of your existing plan, right? You start small and you start with something more practical. Start with one subject, one unit that you're comfortable with, and make a lesson idea where you're sort of asking students to apply different skills. Try to see how the same topic can be taught by uh, helping students inculcate newer skills, and also help. I mean, I think one more useful thing would be just to see samples of how other teachers are doing it, how they're applying different skills in their lesson plan, and how they're uh, inculcating new skills in their students. Another question from Tapas Banerjee is about uh, how can we help slow learners upgrade their knowledge and understanding of a topic or a subject. So I think having skill-based learning will definitely help with this. So the idea is to help slow learners by making learning practical, by making learning more engaging and easier to understand, removing the focus from marks and moving towards mastery instead. Like, and you can do this by having hands-on activities and focus on the doing part rather than remembering. So if the students are able to do, if they're able to perform something or see it happen, um, and it could be live or it could be through a video or some kind of experiment, if they see it happen, it can definitely build their confidence and sort of build like a personal relevance, right? So if you've seen something happen in front of your eyes, it makes learning more meaningful, and it's easier to retain such things. Yeah, so I think learning by experiences and not just theory will help slow learners also learn. And of course, we must keep some things like pace and style of teaching in order to make sure that learners are able to grasp concepts easily and we're not going too fast. Yeah. So these are some of the questions we had in the Q&A section.
Also, teachers, if you're not able to scan the QR, we've also shared the link in the chat box. You can click the link and fill the feedback form.
Teachers, if you have given submitted the feedback form and you have no questions, please feel free to leave the session. And if there are any questions, please do put them on the Q&A section. We'll be happy to address them. Okay, thank you, everybody. We'll be ending the session now.